Welcome to the second part for section 2.4, and we're going to continue with the same group of problems that we ended on the previous video, and it's basically a word type of problem. This one says a mass hangs from a spring which oscillates up and down, and we can give the position P of that item to be 4 cosine of 4t. And it asks what is its amplitude, and just like last video, amplitude is simply the absolute value of the 4, and that happens to be this 4 right here, so that would be 4. And then it does ask what is its period as well. And in this case we're going to take 2 pi and divide by the number that is being multiplied by the variable right here, which is 4, and so the period simplifies to become pi over 2. And it says graph this function over 2 periods beginning at t equals 0. So here we do have a little bit of different directions, and so we do have to modify a little bit what we were talking about. Now, since we want to go 2 periods, first thing I'm going to do, instead of just putting 4 marks, I'm going to put 8. Now realize there might not be 8 marks on your graph, but you can certainly put in any additional marks that you need. And I know that at each period it's going to be pi over 2. So if this is pi over 2, this would be the simple pi out here. And we can fill in other marks. For example, this would be pi over 4, and this would be 3 pi over 4. And we could go on, this would be pi over 8, 3 pi over 8, so on and so forth, but there's really no need. And secondly, our period, or our amplitude, says we're going to go from a positive 4 to a negative 4. And since it's cosine, once again, we do not start at 0, 0. We start at the upper extreme, since there are no eigens that tell us to do otherwise. And then at each mark, it's going to oscillate between the upper extreme, 0, the negative extreme, 0, positive extreme, 0, negative extreme, 0, positive extreme. And then we get to make this nice sinusoidal curve. Even though it is cosine, we don't call it a cosinusoidal, because as you've seen, both the sine and cosine have in essence the exact same look. And so there is the final graph for number 9. The next group asks us to graph the sinusoidal functions using key points. Well, we've been using key points several times, so we're just going to do, in essence, what we have been doing. Number 10, y equals 4 the sine of pi x. Okay, quickly, the amplitude will be the absolute value of 4, which is 4, and the period will be 2 pi divided by the pi that's right here, which simply is equal to 2. Amplitude takes us to go from positive 4 to negative 4. And since we only have to really do one period, I'm going to mark my 4 marks, and the period goes out there too. So that would make that a very easy one right there. We're talking sine, so sine starts at 0, 0, and then we always go up unless we have eigens that tell us to go otherwise. So what we have is 0, upper extreme, 0, lower extreme, 0. And just continuing it on just a little bit further in both directions, we get this nice sinusoidal curve that looks like that. Example number 11. Y equals 1 plus the sine of x. Now here we have an actual shift, and we need to determine, what sort of shift is this? This 1 plus doesn't directly affect the variable x, and so going back to the algebra here, this would mean a vertical shift, either shift up or shift down. And more importantly, since it's not directly affected to x, it actually does behave the way we want it to, so it's going to shift up by 1. And so let's look at what's going to happen here. Now the amplitude, still the absolute value of 1, that's no problem, and the period, nothing is affecting here. So this is just the sine curve, which goes from 1 to -1 and has a period of 2 pi, but what's going to happen is it's going to be shifted up by 1. And so let's look at what that graph will look like. Once again, same thing. I'm going to put the 4 marks, and I know I want to go +1 to -1, but if I shift up by 1, instead of going from -1 to 1, it's going to go from 0 to 2. And this, in essence, becomes our 0 mark, because that's the midway point. And so I'm just going to put that line there to help us gauge where we're going to be. This is going to be 2 pi, because the period is 2 pi, so we can very easily deduce that this would be pi. And so sine starts at 0, 0. Well, this is our new, sort of like our horizontal axis. So I'm going to start at the 0 value, and then it goes up and down, just following the exact same rules. So here at the first place, we're going to go to the upper extreme, back to 0, to the negative extreme, which is now the actual x-axis, and then back up to 0. And so just continuing this whole pattern back and forth, we get something that looks like that. And look at this beginning right here. That's totally messed up. So, because I went way too far down, so it's going to look something like this. The final problem in this group is y equals 4 the sine of 1/2 x minus 2. Okay. Several things we have to deal with. We have to deal with the 4, we have to deal with the 1/2, and we have to deal with the -2. The easy one to realize is this -2. -2 isn't directly affecting the x, and therefore it does behave, and that would mean it's either vertical, either up or down. Since it does behave, that means it will be going down 2. So we will deal with that when that time comes. This number affects the amplitude. The amplitude will equal the absolute value of 4, because that's what's right in front of the trigonometric function here. So the amplitude is 4, and then the 1/2 affects the period, and period is determined in exactly the same way that we have all during trig. 2 pi divided by 1/2, which equals 4 pi. So as an initial value, what we're going to do is we're going to say, okay, we're going to go from +4 to a -4. And we're going to have our 4 marks here, and since the period is 4 pi, on the 4th mark I'm going to put 4 pi, so that would be a 2 pi, and these are pretty simple, so I'm just going to go ahead and label all these. So we've taken care of the amplitude, we've taken care of the period, but this -2 says we're going to shift this whole thing down by 2. So that means instead of going from -4 to 4, we're going to shift this down 2, so it's going to become from -6 all the way up to 2. So that also shifts my 0 line. My 0 line is now going to be 2 below where it normally was. Now all we have to do is start plotting the important points. For example, sine starts out at 0, 0. Now this is our new 0 line, so I'm going to put that there. Now we have to realize it's going to only go up it's going to go from -6 to a +2. So +2 is our upper boundary, -6 is our lower. So at the first mark, we go to our upper boundary. At the second mark, the 0. Third mark, the negative boundary. And the fourth mark right there. And then just extending and making the nice sinusoidal curve yet again for the multiple whatever time. This is the equation that, or the graph that we get. One group of problems in this particular section is if we're given a graph, what is the equation of the line? And so we're going to begin with number 13. Now, things we need to look at, is there a shift? Is it shifted up or down? We need to look at, is the amplitude changed? And what is the period? And so if we look at number 13, this one's not quite so obvious, but realize that in order for it to be a period, we need to have an entire cycle going through there. And all we really see is the bigger part of half of one. Now, if we look at this, half of the period appears to be from -3 pi over 2 to a +3 pi over 2, which is 6 pi. That would be the half of the period. And so what we need to do is we need to realize if, I'm sorry, not 6 pi, 3 pi. 3 pi from the -3 pi over 2 to the +3 pi over 2. So half of the cycle would be 3 pi, therefore the entire period would be 6 pi. And so what we need to first of all, or next thing we have to realize is we've got an amplitude. The amplitude appears to be going from -4 to +4, so our amplitude would be 4. So think about where that's going to go. And then the period, we know, is 6 pi. We've determined that that's 6 pi, but it's going to have to be determined by 2 pi over omega. So we need to do a quick calculation here to determine what omega is so that we know what to put in its proper location. So we find out that omega is equal to 2 pi over 6 pi, or 1/3. And so then just putting this into the equation, the only thing we have to determine now is, are we talking sine or are we talking cosine? And we look right at the 0 mark, it's at 0. So that tells us it's a sine. If it was at the positive end, we would make it the cosine. Okay, now we know it's a sine. The amplitude is 4, so that has to go right out here. And omega, in this case, is 1/3. So we have to be sure and put 1/3 x. Number 14. What I'm seeing here, the amplitude goes from a -2 to a +2, and so the amplitude would be 2. The period from one upper crest to another upper crest appears to be pi over 2. So that means 2 pi over omega is going to equal pi over 2, because I can tell that the entire period is pi over 2. Some quick calculations makes omega would equal 3. When you multiply by omega and then divide by pi over 2, correction, that will equal 4. Omega will then equal 4. So, not period, but omega is equal to 4. Period is pi over 2. And so, plugging it in, we first of all look and see at the 0 mark, where x is equal to 0, we're at the top. So that means it's going to be a cosine. The amplitude number goes right here, and then we have to put 4x right there. Final example for this section, number 15. Now 15 is given as if we're looking at a graphing calculator. It's very simple to realize our amplitude is 4. It goes from -4 to +4. And the period from one hill crest to the next appears to be the distance of pi, because we can go from 0 to pi, and we've gone all the way downhill and then all the way back up. So as far as the period is concerned, or how we deal with that, we know that the period is pi, and that has to equal 2 pi over omega. Well, solving for omega, omega equals 2. So finally, all we have to do now is to determine, is this a sine or a cosine? Since we started at the top when x equals 0, that means it is cosine. We put the amplitude here in front and then put the omega right next to the x value.